Hey guys, we have a test on Thursday and Friday over multiplying and dividing monomials. So I wanted to go over a few of the problems from page 191 in your workbook. That way you have some of the problems worked out and you can kind of see a little bit of what the test will be like. So if you want to reference your workbook page 91 when you're looking at how I'm working these out on here, so that you can kind of see examples of a few of these. Okay, so the first one that I'm going to work through is a relatively simple dividing monomials problem. So this is number 2 on your workbook page. 9 to the 12th power over 9 to the 8th power. So when you are dividing monomials and you have the same base, it doesn't matter or if it's an exponent or a number, like this right here is a number 9. If you have the same base, you're dividing monomials, you can simply subtract the exponents, so 12 minus 8, and that will be your new exponent on the base. So these two things equal each other. I'm going to draw out why this works. So 9 to the 12th power is the same thing as 9 times itself 12 times. So 9 times 9 times 9 times 9 times 9. 1, 2, 3, 4, 5, 6, 7. And then on the bottom, we have 9 times itself 8 times. Okay, so we know that anything divided by itself is 1. So this is 1, this is 1. We can simplify each one of these sets right here. And what are we left with? 9 times 9 times 9 times 9, or 9 to the 4th power. Okay, so that's how that works right there. Let's do another pretty simple one. This is number 11. So we have negative 21 times w to the 5th times x squared over 7 w to the 4th x to the 5th. Okay, so we're looking for patterns of the same base. We're looking for exponents that have the same base so that we know we can work with those. We have w to the 5th and w to the 4th here, x squared, x to the 5th here, and then we have our numbers, negative 21 and 7 here. These we're just going to divide. Negative 21 divided by 7, well, that's negative 3. We're going to do the same thing here that we did before. Subtract the powers. 5 minus 4 is 1. We don't actually have to write the 1 here. W to the 1st power is the same thing as just W. So we can leave it like that. And then x squared over x to the 5th, that's 2 minus 5. X to the negative 3rd power. We're not quite finished yet. If you have anything to the negative power, you're going to flip it. You're going to switch it to the reciprocal. So x to the negative 3rd is the same thing as 1 over x to the 3rd. These two are equal. So we're going to take this and bring it to the bottom. So take it to the bottom, and that goes away. So this is our final answer, negative 3w over x to the 3rd. Okay. Let's do another one. Let's do number 13. So we have 4p to the 7th over 7r squared. All of this is squared. When we have multiplication or division inside the parentheses and everything inside it is squared, we're going to square everything. So first, this is going to apply to each individual thing inside of this parentheses because it's division or multiplication on the inside. So first, let's do 4 squared. So 4 squared is 16. Then we'll do p to the 7th squared. When you have a power raised to a power, you're going to multiply that. Then on the bottom, 7 squared. And then r squared squared, when you have a power multiple or raised to a power, you're going to multiply that as well. And that's your final answer for that one. All right, and then I want to show you number, let's see, I want to show you number 22 because there's something that I hope that you can catch so you don't have to do a lot of extra math, extra work with the powers. All of this is raised to the 0 power. So you know that this is applying to everything inside these parentheses, just like it was in the last one. But you also know that anything raised to the 0 power equals 1. So without working through all of this, you can just say this is 1. Anything raised to the 0 power is 1, even if it's a bunch of stuff like this, even if it's a lot. Anything raised to the 0 power is 1. All right, let's do one more. This one is going to be from page 92. So the next page, dividing monomials. This is a So just like we talked about earlier, when there is something without an exponent, you don't see an exponent there. It's to the first power. Just like we all know that this a also has a 1 here. Those ones, you don't have to write them because an a by itself means the same thing. So we know these two bases are the same. We can subtract 4 minus 1. And then we subtract 6 minus 3. We know that when we are dividing monomials like this, we subtract the exponents, and that's what you've been doing. But we also need to remember from our last lessons that when you are multiplying the monomials, what to do. Okay, so we have 4g cubed. This is from page 90. Number 6 on page 90 if you want to keep following along in your workbooks. All right, so when you are multiplying monomials with the same base, you're going to add the powers. When you're multiplying a coefficient, the number that's in front, you still just multiply. That rule is the same as it always has been. So 4 times -2 is -8. Now we have our g's here. These are the same base. They have powers, same base. We're going to add the powers. And then what we have left over, there's nothing that matches this. So we can't do anything with it. Just leave it the way it is. So if you could do all of the ones that we just saw, you know, all of those rules, you can combine them together to solve different problems. You will be A-okay for the test on Thursday and Friday this week. Let me know if you have questions, guys.